so we're solving rational equations and inequalities in one variable. And we know that the rational equations contain fractions. We can eliminate that fraction by multiplying each side by the LCD, which is the least common denominator. Okay, but if we solve this way, well, last time I passed, that can yield an extraneous solution. Okay, so you can have an extraneous solution. So we are going to be checking our solutions today, but I'm going to show you a quick way to check some of those using what we know about domain. Okay, so we have to check our solutions there. All right, so this is to solve each equation, check your solutions. Okay, and our first equation is, this is a 9. 9 over x minus 7 minus 7 over x minus 6 equals 13 over x squared minus 13x plus 42. Okay, so when we have one of these, if we can factor, that's what we're going to want to do first, is factor what needs to be factored, and then we're going to multiply by the LCD. Okay, so we're going to factor here, so go ahead and factor, and then I want you to write out what your LCD is going to be. We'll write this out on the side. Notice if you have a positive here, you have to have the same sign. So this is a minus and a minus. Oh yeah, and I made this before this year, so the -6 and -7 is just going to work here. Okay, so earlier today I think people were forgetting how we do the LCD. Remember, all we have to do is look at the denominators. So this denominator has a factor of x minus 7. That has to be part of the LCD. This denominator has x minus 6. So that has to be part of it. And then this one has both, so we're good. When you are multiplying each side by the LCD, okay, you are going to be multiplying this whole thing by x minus 7 times x minus 6. And then same thing here. I don't have room to write that. I'm going to write that in the next one. I'm just going to put times there. So sometimes what I recommend is that you distribute and then do the canceling out. So we're going to write the whole thing out this first time. Some of you are going to like that because visually you're going to be able to see what cancels. And then we'll talk about some common mistakes when we're doing this, okay? All right, so when you're canceling those out, you can cancel out whatever is a common factor. So if you have x minus 7 here and x minus 7 here, those can cancel. So then what you'd be left with is 9 times x minus 6, and I'm just going to write it like that for now. Okay, when you do this on your own, of course, you can distribute. And then here you have the x minus 6 and the x minus 6 that cancel. So it's a negative 7 times x minus 7. And then here you can cancel out the x minus 7 with x minus 7, the x minus 6 with x minus 6, and then that's equal to 13. Okay, what you cannot do is you cannot cancel out the x minus 7 and the x minus 7 here, and the x minus 6 and the x minus 6 here, and just say that this is 2, right? 9 minus 7 will be 2, so you can't do that. You have to distribute, and then you can start the cancellation process. So now we're going to distribute. We have 9x minus 54 minus 7x plus 49 equals 13. Okay, so I want you to go ahead and solve that for x. That's just an algebra equation. Alright, what do we get for x? Yep, 9 is fine. Okay, so you want to get all of your like terms together. We got 2x minus 5 equals 13. Add over the 5. Divide by 2. Okay, now when you're doing your check, all we're going to do is use our domain. Okay, so with the check, we're going to be using our domain, okay? We know if we have a fraction that we can't have the denominator equal 0. Okay, so if the denominator can't equal 0, we have to set the LCD equal to 0, and we're going to solve. Those are going to give us the restricted values. Okay, so we're going to check the domain. We're just going to do a quick check. We won't have to plug anything back in. We can just see if it's one of the restricted values. So our LCD was x minus 7 times x minus 6. Okay, which means if I have x minus 7 equals 0, x can't be 7. And if x minus 6 equals 0, x can't be 6. These are the only two values that would make this extraneous. So is our answer 7 or 6? Nope, which means we do not have an extraneous solution. Okay, so that's how we're going to do the check for this. So this is our solution. X equals 9. We're going to write a little note for this just so we understand why we're able to do this. Okay, so since x cannot equal 6 or x cannot equal 7, there are no extraneous solutions. So the only things that produce extraneous solutions are going to be those values excluded from the domain. Okay, because if you plug these back in, you get 0 on the bottom. That would give you an error. That would be extraneous. So if it's not one of these, you don't have to worry about it being extraneous. So isn't that kind of nice? Instead of things like that, better than plugging it all back in. Alright, so with part B, I want you guys to start just doing the first couple steps, which is the factoring and then the LCD. So you have x minus 8 over 2x plus 2 plus x over 2x plus 2 is equal to 2x minus 3 over x plus 1. Okay, so I want you to factor and find the LCD. Alright, ask tell us how you factor this. Yep, what'd you take out? Yep, so 2 times, what did you get inside there? X plus 1. Okay, so when you're factoring, it could just be taking out the GCF, okay? Now, when you're doing the LCD, just start with the first denominator. The first denominator is 2 times x minus 1, so you have to have that as part of your LCD, okay? The second one is the same, okay? And then the third one already has the x plus 1, so this is going to be your LCD. This one is a little bit different because, see how you have the same denominator? What could you do with these two? Yeah, you can add them together. They have the same denominator, you can add. That doesn't happen a lot, but it does happen sometimes. Okay, so if you add those together, is it okay if I just write 2x minus 8 on the top? It's x and x. Should I say add the numerators? It's just going to remember. I don't want you to add the denominators. Okay, so you can add the fractions because you have the same denominator. So when you add, remember, denominator stays the same. Okay, x plus x, 2x, negative 8 drops down. Okay, so then we're just going to multiply by the LCD. Okay, so we're going to multiply this side by 2 times x plus 1. And then we're going to multiply this by 2 times x plus 1. Okay, so with these problems, I want you showing that you are multiplying by the LCD, okay? And what's nice about that is when you can cancel these out, you see 2x minus 8 is equal to, now here, you have 2x minus 3 times 2. Even though this is behind it, you are still going to distribute. Okay, so go ahead and distribute and then solve that for x. And then see if you can check your domain with that. Alright, so what do we get for our value for x? Yeah, negative 1, right. Alright, and then we're going to check with the domain. So we have 2x minus 8 was equal to 4x minus 6. I always like to keep the x's positive, but you don't have to do it like this. Alright, so now we're going to check. When we check, we're going to use the LCD. Okay, so when you check your domain, you have 2 times x plus 1 equals 0. Now, if you just have the 2, 2 equals 0 would be one of the factors, but you can't solve that for x, so that does not give you any solution. Okay, you can't solve for x there. Here, it's x equals negative 1, so x can't be negative 1, but that's what we got. So that means our solution is extraneous, and then what would we write for our answer? No solution. Good. And then sometimes the book will write the no set like this, no solution. So if you see that, it means the same thing. All right, nice stuff there. I think we could work. You guys all try and aren't going out, so that is great. All right, so should you guys try to do this one all by yourself? Oh, yes. Okay, so we're going to factor LCD, multiply, once you factor and you find the LCD, make sure that you distribute the LCD. Alright, so maybe I want you to factor for the first one there. Good, 2 minus 3 and 2 plus 3. If you are still struggling with the LCD, remember that you are just looking at the denominators, okay, and then those are what has to equate to your LCD. Okay, so for part C, your LCD is t plus 3 times t minus 3, and that's what you have to distribute. Okay, when you are writing this down on your homework, okay, I'm okay if you want to just write the multiplication like this. You write down the problem, okay, and then you can write down here the t minus 3, the t plus 3, and then if you're comfortable distributing, okay, here, these are going to cancel, so you're just left with 8, but here, the t plus 3s are going to cancel, and you're going to be left with 4 times t minus 3. Okay, so if you want to we're going to multiply those together. Okay, if you're somebody that's more of a visual learner, you might want to write this out next to each of them so you can do the cancellation to make sure that you don't just cancel these out and then forget to multiply this one. You do have to multiply both there. Okay, now this is a little bit different because I have t squared. So when that happens, what do we have to do?
That's not doing it.
We're going to have to do some factoring. Okay, so then we're going to move everything to one side. Okay, and then I'm going to add 4. I have t squared minus 4t minus 5. Okay, so when you factor, has to multiply to a negative, add to a negative, so negative 5 and positive 1. Okay, and then based on that, either 2 minus 5 equals 0, or 2 plus 1 equals 0. So t equals 5, or 2 equals negative 1. And then, of course, we're going to use our domain to check. Okay, so when you're checking the domain, it's just whatever makes that denominator 0. So if you have x plus 3 times x minus 3 as your LCD, you know that x can't be negative 3 or positive 3. Okay, so is that in either of our answers, negative 3 or 3? Nope, so then that means both of these answers are part of our solution. Okay, so t equals 5 or t equals negative 1. So you can have 2 solutions, you can have no solution, you can have 1 solution. Okay, so we can always refer back to the domain to help us with that. Okay, and then the other thing we're going to learn about today is solving rational inequalities. And so we're going to combine a few things that we did on the front with a few things that we learned in semester 1 when we were solving inequalities. Okay, so you might remember we used to do interval lines, and we had to split up the lines and do the checking with our intervals. Do you guys remember that? Okay, so you have the negative 2 and 0. Do you remember how to set up those intervals there? Rings or vague, now. Okay, so when you're solving rational inequalities at the top of the next page, okay, you do have some steps that you can follow. Alright, so the first thing is you want to find the excluded values. These are the values for which the denominator is 0. Those are going to go on your number line. Then you are going to solve what is called the related equation. The related equation is what you get when you multiply by the LCD. And sometimes I forget that we can write the related equation, and sometimes I still write it as an inequality. Okay, but you can just solve the related equation. The process is going to be the same. Okay, and then we're going to use the values determined from those previous steps to divide a number line into intervals. So the previous steps are going to be steps 1 and 2. We need the values from both steps 1 and 2, not just step 2. And then we are going to do a test point, which you guys might remember that. You're going to test the value of each interval to determine which ones satisfy the inequality. And satisfy the inequality just means what makes it true. Okay, so you're going to find which ones produce the true statements. Okay, and then I think once we go through it once, some of this will come back to you from earlier. Alright, so we have 3 plus 2 over t is greater than or equal to 8 over t. Okay, so I want you to write down what the LCD is, what you think it is. Okay, so remember, whenever you're trying to decide the LCDs, just look at the denominator. What's the only denominator we have? T, so that's just it. That's our LCD, okay? So your LCD is T, which means we are going to eventually have to multiply by that. Before we do that, though, it says state the excluded values. These are the values for which the denominator is 0. So if this is the LCD, we just set that equal to 0. Okay, so this is an excluded value. Okay, you just set the LCD equal to 0. And this is going to be one of our key points here. Okay, the second step is to solve the related equation. So to get the related equation, we're just going to multiply both of these sides by t. When you do that, you are distributing to every single one of these terms. Okay, so I'm going to write the original equation down. Leave a little space here. And then I'm going to show you what it looks like when you multiply each one by t. So when you distribute, 3 has to get multiplied by t. 2 over t multiplied by t. 8 over t multiplied by t. Okay, so you can either write it like this or you can put it in parentheses, whichever way you want. But then you'll get 3t plus 2. And then we're going to do the related equation, so you can do equals 8. So here the t's cancel, here the t's cancel. This is what we call the related equation. Okay, and like I said, sometimes I forget to change it to an equation and I just put the inequality. That is not a huge deal. Okay? You are going to solve it just like an equation. So subtract 2 from both sides. Is that a question? Yes. What's the question? So you multiply by your LCD, okay? You're going to solve that related equation, and then we go to step 3. So we're going to use those values to divide the number line into intervals, okay? And then we're going to do the test values. So we're going to do that down here. This is steps 3 and 4 together. Okay, so on your intervals, you have 0 and you have 2. So in step 1, we found the 0. Okay, in step 2, we found the 2. And then do you guys want to try to write the inequalities? Yeah, what's the first one? That's something to do with 0, but what is it? What's the inequality? More. So this part of the number line is all what compared to 0? Less than. Yep. And then because it has the equal to, it's just going to be t is less than or equal to 0. Okay, so it's just t is less than or equal to 0. Only equal to because of the original equation. Okay, and this one is all the values that are greater than 2. So t is greater than or equal to 2. Now do we remember how to do the middle one? What? Yeah, 0 is less than or equal to t, which is less than or equal to 2. Alright, so then we're going to pick our test points, our key keys. Okay, so our test points just have to satisfy these inequalities and they can't be the key value. So it can't be 0 and it can't be 2. It really wouldn't make sense for these anyway because 0 would be in both. So what's a value that's less than or equal to 0? Negative 1. Yep, between 0 and 2. 1 greater than 2. 3. Okay? And you don't have to choose those in particular, but those usually are the most common. And then what we're going to do now is we're going to plug them into our original equation to find out if they are true or false. Okay, so we're going to separate this. Alright, so if you have negative 1, you have 3 plus 2 over negative 1 is greater than or equal to 8 over negative 1. Okay, when you do this, I'm fine if you just simplify that. You guys all have different levels of what you're comfortable with. So 3 minus 2 is less than or equal to negative 8. 1 is greater than or equal to negative 8. Is that true or false? 1 is greater than or equal to negative 8. True. Okay, so I want you guys to plug in 1 into the original equation. And then I want you to decide if that one is true or false. Make sure you have a readable inequality. Okay, so when you plug in 1, really, when you're dividing by 1, that's not too bad. Okay, even the fractions here are not too bad. Because when you are plugging those in, you can just add and make a mixed number. So for this one, you have 3 plus 2 over 1 is greater than or equal to 8 over 1. Well, 3 plus 2 is 5. Is 5 greater than or equal to 8? No. So that's false. Alright, and then when you plug in 3, okay, you have 3 plus 2/3. Okay, 3 plus 2/3, just write it as 3 and 2/3. And then change this into a mixed number. How many times is 3 going to 8? 2 with 2 left over. So is 3 and 2/3 bigger than 2 and 2/3? Yeah. Okay, so then your solution is just going to be your true intervals. Okay, so your solution for this is going to be t is less than or equal to 0 or t is greater than or equal to 2. Okay, so whatever is your true interval, that's going to be your final answer. Okay, is some of this table stuff coming back to you? Unfortunately, do remember. Okay, so 1 over 2m minus 3m is less than negative 5 over 2. Alright, I'm feeling good about this one for you guys. You guys write down what your LCD is. I'll come around and check. And then I want you to multiply to get that equation. Okay, if you're scared that you don't have the LCD, okay, I'll check it before you go to the next step. Before I get done, I'm feeling good just somewhat of so far. Alright, so Elena, what's her LCD? 2M. So we'll use our remote then. Oh, okay. Alright, so yeah, your LCD is 2M. So when you're deciding your LCD, remember, I always just start with the first fraction. 2M has to be part of it. M, already part of it. 2, already part of it. So we're good. So now we're going to multiply both sides by 2M, okay? And you can write out the problem, and then you can write what you are multiplying by. Like I said, for some of us, we're going to want to write it out. I know that takes an extra 3 seconds, but for some of us, it's worth it. And I'm not being facetious when I say that. Some of us are more visual, and we're more tactile, okay? Facetious, yeah. I'm getting you guys ready for the ACT, or SAT. I know, we used to take the ACT test that while. Yeah. It means like I'm not like making fun of it. Like I'm not making a joke. Okay? Yeah. Okay, so then this is 1 minus, here the m's cancel. Negative 3 times 2 is negative 6. Here the 2's cancel, so negative 5 times m. And then the related equation is just negative 5 equals negative 5m. And remember, like I said, sometimes I even forget to change that into an equation, but it honestly does not matter until the last step, as long as you're getting your m value is 1, so you have your 2 values. Okay, so this is what you get from step 2. Here, I'll put my step 2 here. In step 1, whenever you get your LCD, just set that equal to 0. If you set 2m equal to 0, what is m going to equal? M is going to be 0. Okay, so it just says what's the excluded value, but these are the 2 values that you are going to put on your number line. Okay, so this is going to divide up our number line. Okay, so I have 0 and 1. You do have to put them in numerical order. And notice that this one does not have an equal to. So this is just going to be m is less than 0. M is greater than 1. Or m is in between the two. Alright, so let's do our test points. Okay, and you can pick I'll let you pick your own test point. You just want to pick your own, not the influence. Alright, your own test point here. Okay, so this has to be in that interval, and it can't include one of the key values. So it can't be 0 and it can't be 1. Alright, so when you are finding a value less than 0, what did you guys choose? Negative 1, great. Okay, between 0 and 1? 1/2, great. Okay, greater than 1? 2, alright, I like it. And then we're just going to plug this into the original, okay? So when I plug it in, 1 over 2m, this is a negative 1. So this is 1 over, can I just put negative 2, is that fine? So when you guys are plugging it in, you can do the same thing. And then it's a minus 3 over m. So negative 3, this one I do want to plug in so I can just show you guys what's happening with the negatives. Okay, I don't try to do too much in my head. I like to get it on paper and decipher it. So a negative divided by a negative is a positive. And you can think of this as negative 2.5. 3 minus a half is positive 2.5. So 2.5 is less than negative 2.5. True or false? 2.5 less than negative 2.5. No, false. Alright, when we plug in a half, sometimes with fractions, it helps to see it. Mm-hmm.
I know that it doesn't get us, but technically, is it not possible to Like you can only do two outside or on inside.
Yeah. And we're going to talk about that
But
more.
you still have to do the one.
Yes, for these guys. Okay, so there are some rare cases where the ones next to each other are both the same, but it is very rare. Okay, so for this one, 2 times a half, it's just 1. 1 divided by 1, 1. If you're dividing by a half, it's the same thing as multiplying by what? 2, the reciprocal, right? So negative 3 times 2 is negative 6. Okay, so it's negative 5 less than negative 2.5. Yes. True. Okay, and then the last one, when you plug in 2, 1 over 2 times 2 is 4, minus 3 over 2. Okay, and then you can get a common denominator. So 1 minus 6 is negative 5 over 4, less than negative 5 over 2. So this is negative 1 and a fourth. It's less than negative 2.5. That one is 1. Alright, so then your solution is only going to be what's true. For this one, 0 is less than 10, which is less than 10. Alright. The last one you're going to notice is a little bit different because here we only have one variable.
Are you kidding me?
I never did about the notes. Alright, so let's try this one. Okay, so x over x plus 2 plus 1 over x minus 1 is less than 3 over 2. Okay, so the first thing we're going to do is we are going to write out what the LCD is. What are we doing here? Alright, so Jeff, tell me something that has to be part of the LCD. What? Both of you. Whoever talks first, what is it? Okay. X plus 2. Alright.
X minus 1.
X minus 1. Okay, what's the last thing I need? 2. Okay, that's your LCD. That's what you're multiplying everything by. Okay? So when you're doing that, you can multiply each one by this. And then like I said, if you are a visual person, sometimes it helps to write out the distribution so that you can do the cancellation. Okay, you have to multiply by everything. Alright, so I want you guys to find the related equation from that. Alright, and then once you guys have that, you can distribute. Okay, I like doing the cancellation so I can see what's left. So 2 times x minus 1 times x. If you want, you can write it as 2x times x minus 1. Here the x minus 1s are going to cancel, so you're left with 2 times x plus 2. And then I'm going to change it to equals since we're doing the equation. Those cancel, so you have 3 times x plus 2 times x minus 1. Okay, and now we can solve for x. So 2x squared minus 2x. Okay, you are going to have to FOIL and distribute, so I'll give you some time to do that.
On the side to us is your problem.
Alright, so negative 2x and 2x cancel out, so you have 2x squared plus 4 equals, and then you do have to FOIL, so 2 minus 1 is 1. There's a lot of algebra skills involved, skills that we have, and you're strong. You don't have to do it by their formula very faster. Okay, so then once you get everything to one side, then you can factor. Okay, so it has to multiply to 10 but add to 3. So what are my values? Positive 5, negative 2. Great. Okay, so then when I set those equal to 0, I have x equals negative 5 or x equals 2. Okay, now what is different about this one is we have 2 values here, but remember, we have to use 2 values from the first step. Okay, so from the first step, if this is our LCE, okay, if you have 2 equal to 0, you don't get anything from that. But if you have x plus 2, x equals negative 2, that is one of the values. X minus 1. Okay, so all the values that we have to have on the line are 1, negative 2, negative 5, and 2. So we're just going to put them in numerical order. Okay, so what's going to be the lowest one? Negative 5. After that will be, well, so we have negative 5, what comes after that? Negative 2, what comes after that? 1, 2. Alright, so for this one, let's write out our intervals, and then we're going to talk about special rules. I always like to start here first with the greater than, x is greater than 2, or x is less than negative 5. Okay, and then the rest of these are just in between, right? So in between negative 5 and negative 2. In between negative 2 and 1. In between 1 and 2. Okay, so if we're thinking about our test points, if it's less than -5, -6 would be good. What's a good value between -5 and -2? -3, yeah. Between -2 and 1, 0. Between 1 and 2, 1.5, great. And greater than 2, 3. Okay, now we 1, 2, 3, 4, 5. If you have more than 3 intervals, okay, I'm only going to make you show work for 2 of them, and then you can follow the pattern that we've noticed. Okay, so if you have more than 3 intervals, yeah, you only have to show it for 2. Show work for at least 2. Thanks. Okay, if you have more than 2 intervals, or more than 3 intervals, show work for at least 2, and then you can follow the pattern. Yes, what is the pattern? What have we noticed from the last 2 examples? Yeah, so they alternate, right? False, true, false, or true, false, true. Okay, so you can pick any 2. Which one do you think is going to be the simplest? Yes, that's what I would do as well. Okay, so I would pick the 0. Guess I don't need my lines for all of them. So if I plug in 0, if you have 0 over 2, that's just going to be 0. Plus 1 over -1 is less than 3/2. So this is 0 minus 1 is -1 less than 3/2. Yes. Okay, so that interval is true. The other one, I would pick one of these to make sure that that one's false. Okay, and if you did get one next to it that was true, I would do another one just to make sure you know which one went wrong. Alright, so for -3, if I plug that in, I have -3 over -3 plus 2 is -1 plus 1 over -3 minus 1 is -4. Okay, so I have 3 minus 1/4. There should be 2 3/4. And then is that less than 1.5? No, so this would be false. So then our pattern would be, this one is true, this one is false, this one is true, this one is false, this one is true. So you have to include all of the true ones in your solution. Alright, then stay quiet. Okay, so your solution should be x is less than -5, or between -2 and 1, or x is greater than 2. Okay, that is going to be your final answer. Okay.